Hello, my name is Oscar Rodriguez. Just a little bit about myself. I'm a product marketing manager of MPS from JetBrains. I joined JetBrains last year, and before that, I was 5 years in the entrepreneur and startup world. So my main expertise is in the product development of the projects from the companies. So I prepared this talk called JetBrains MPS. What is a domain-specific language and why should we care? So before start, I would like to make a very short survey. Can you raise the hand who knows what is domain-specific language? That's good. Now, can you raise the hand on the people that know what is MPS? Still good, okay. Don't worry, I will explain that. Okay. First, I want to start with general purpose languages. The general purpose languages are the programming language that we know quite often. It's Java, C, Ruby, and it takes between 1 and 2 years to master. That's an average time. So now imagine that you can learn a programming language in 2 or 3 days. How is it possible? So, well, actually it's possible when you increase the higher level of abstraction. This means that you hide complexity. You don't need to show, like the user doesn't need to learn all the fundamentals of programming. They don't need to learn algorithms, all the syntax of the language. And we have done this before. So around 50 or 60 years ago, there were developers coding in machine language, in binary. Then they moved to assembly language, to a language where it's like higher level of abstraction. And even people from the machine language were already like, they didn't want it to move. Then from assembly language, we moved to the third generation languages, which is Java, C. And what would be the next step? So, well, the next step would be domain-specific language, which that's the thing that I want to explain. Okay, first I would like to give you some examples of what is a domain-specific language. And these are examples based in our experience as MPS, which is the tool that I represent. Just for you to know all the examples, we've done it with MPS. After like the presentation, I will give you just another examples of other tools to make these domain-specific languages. First, this is the language from Martin, the definition of domain-specific language from Martin Fowler, which is basically a loud mouth in the technical era at this moment. Domain-specific language is a computer programming language of limited expressiveness focused on a particular domain. Basically, it's a programming language focusing on a domain or a specific problem. Just for you to know, JetBrains MPS is an open source language workbench to create domain-specific language. It's basically a tool to create DSLs. Well, JetBrains is well known for having different kinds of IDEs, IntelliJ IDEA, and so on, and Kotlin and MPS. So who is using DSLs? Okay, this is one of our customers' clients in Germany. This is a German insurance company. So this is a Word document. This Word document, how they were doing before, they were creating this Word document, the insurance people, the people that know how to all the rules about the insurance world in Germany. They were creating this document in Word with any of the fancy tricks of an IDE, just pure text. And they were sending this document as requirements to some outsourced company in India to create C code from it. So then when they create the C code, they send it back and they insert it to the system. So you can imagine there will be a lot of problems in the whole process. Because from one side, the Indian people, they don't know anything about insurance. They don't speak German. From the other side, the insurance people, they don't know coding. So this was a problem. But in this specific document, there's it's very structured. So you have functions, well that says functions. Of course, in the insurance world, and insurance actually, in the company world of insurance, you have package type that it can be kind of libraries. You have attributes that can be properties. You have this kind of documentation and some expression, math expression that is happening. So even if it's just a text, a Word document, it's very structured. So what this company decided to do is to create a DSL so they can avoid this sending the document to the outsourced company in India. So they create one DSL, which is this one, which is very similar to the Word document. So now, the same people that they were filling in the Word document, now they're filling in the DSL, which is very similar, and this DSL generates C code, the C code that they need. So in this way, you just keep the outsourced service. And by having a DSL and inside, well, in this case in MPS, you have all the tool support, which is code completion, refactoring, everything that we know as a coders that we have in IDE. Now these people that they are not developers, they also have it. This is also one of my favorite examples. This is from Siemens, so from the division of health. So this Siemens right now is doing a DSL that they work with the tomographies. The tomographies is like the picture that you get in these kind of machines. So what it was doing before, it was the practitioners, the doctors, they were creating these requirements in different Office files. They were sending it to the developer using different systems, different software, to then input. It was basically scripts to input to the machine. So what Siemens they done, they create this DSL just to communicate from the doctors directly to to create the scripts needed to work with the tomography. And of course, you can generate reports on demand. I don't have an example here because it's not public, so I cannot really show it. I just want to mention it. Okay, this is something that is possibly done because specifically in MPS, we use projectional editing. Projectional editing is a technology where normally before, like how you code now is you have your logic, then you write text, and there's a parser that moves converts this text to an abstract syntax tree, and then you send it to a compiler. In MPS, we don't have parser. You are writing directly in the abstract syntax tree. So it looks that it's text, but actually you are really writing in the abstract syntax tree. And the whole tool helps you to just keep, the tool tells you what you can write in there. I will give you some examples, don't worry. Well, just for you to know, this is like the abstract syntax tree of this statement. So you have the multiplication where one part is the variable C and the other part is the addition equation plus A and B. This is how basically like the people will see the code or this pseudo code, and this is how like MPS sees this pseudo code. I will show you. Okay, the benefits of having projectional editing is that you are not constrained in text. You can create graphs, you can create diagrams, math notation. So in this way, also text, of course, but you give more opportunities to use different notations for the specific problems. Okay, now I think it's time to show you something. Okay, I prepared 2 demos. The first one, I want to show you like an example that we already have, and the second part of the demo will create a very simple language so you can have like an idea of what can be done. Okay, I'm good on time. Okay, this is a voice menu system. The voice voice menu system. The voice menu system is the recordings that you hear when you call a company, and they have different options for a specific key that you dial. So this is, for example, you can see JetMobile feedback is like the sound that you receive, like, thank you for calling the company, press 1 for this, press 2 for that, whatever. This DSL was focused not for programmers, was focused for the receptionists and secretaries, people that know the daily basis who is available, who is not available, who is on vacation, who is like a business trip. So they will need they need like one DSL that they can modify. So this DSL generates 4 languages: Java, HTML, XML, and asterisk, which I will show you. So for example, um, I don't know if it's, can you see it? It's a little bit blurry. Wait, maybe. Okay. Anyway, I will try to explain you. Basically, like the whole tool helps you to create a new, for example, a new option. In here, there's says one button, which I have to choose the other key, the other number when somebody will call. So for example, down there is the numbers that are available. So I can choose either from here, either from the keyboard, or we even have like this context action that helps you to give you the options that you need. So for example, when they press 5, they will go to sales. I'm writing sales. And then I have to set up what is sales. So when they press 5, what is going to happen? Okay, I go here to sales to see this option says back, direct call, get information, hang up, basically all the options that you have for this voice menu. Let's say it's direct call, and you just put the number of the person of sales. So I just add one new request or one new option of this DSL, and I mean it's very clear, it's very easy. It's not. This is the point that I'm telling you that is kind of the pseudocode. Now let me just generate. For example, as I told you, you can generate different languages with this. First, I will generate. Okay, let's generate XML. So if you go here, preview generated text, this is XML of this logic of the code. So this is for option if you need, like, if there's a voice menu that needs XML input. So you can also generate HTML, which also is very interesting. You just need to change the language that you're targeting. So now I'm generating HTML. And the benefit of here, you can even they give you the opportunity to use even to create a web visualization. So in this way, I mean, this is just an example, of course, as a sample, but I mean, they give you the opportunity to even show like the whole voice menu in web just by generating HTML. Now I will generate Java, so you can. I'm just basically changing the language that I'm targeting. Voice menu Java. And then in Java, I generate Java code, which is that. And also, we also generate a Java application that helps you for testing, actually. I don't know if I have sound. Okay. Okay. Well, basically, it's.
For technical support, press 3.
Okay, the point here is like you have this application of Java made in Java for testing, basically. I mean, the user that is using this voice menu can even test. And last but not least, we generate asterisk code or asterisk scripts. Asterisk is one of the main systems that creates this voice menu for a lot of companies in the world. I read that in their website that they have 30% of all the voice menus are made with asterisks. So for this sample, to make it more real, we decided to also generate the asterisk code that is needed. So for example, if I generate here the asterisk code, I generate 2 config files, this one and this one. These files are the files that you need to upload it to the server, to the asterisk server, and it's already, I mean, it already has all the logic. I know it doesn't sit so well, but it's just basically the scripts how asterisk works. Maybe for a developer, it's not that hard to really modify this kind of scripts. But for somebody that is not technical, it can be a really pain in the ass. Okay, and how much I have time? Okay, I will make a very fast voice menu so you can know how it works. Workspace, I will put voice menu, TechMeetup. And then in here you put the options. As I told you, that even the IDE, the tool gives you all the options that you needed to create like this specific problem or domain. So when I press 1, I want the activity to go to technical. Then technical is created. So what is the action that I need to happen when they create technical? Okay, get information. And now, for example, if I want to create an extra event, you can either use with your mouse or trackpad the option to create a new event, or you can use just spacebar, no, enter. So you generate like the next option, and also gives you like the whole benefits of the whole all hints to create the next step. In this case, you have to set up the option. So you set the option, also direct call 45. So in this case, we just generate like a very simple voice menu. Okay, now let's go back to the presentation. Okay, this is the next language that I want to create. I will create a constant language, which means that you will write in text basically your names, well, values, and they will generate Java constant variables. This is a very simple language, but you will get like an idea of how it's done using the tool MPS. Okay. Just also a little bit heads up. I mean, MPS is a powerful tool, but also it's very complex. So the purpose of this example or demo is not to learn MPS. It's mostly to know how it works. And if you are interested, you can just do tutorials in our website, okay? So I will go from scratch. I will create one project. So I have to name my language, which I will name Constance 38, and I'll create a sandbox. So this is like your initial window that you get when you create a project from scratch. On the left, okay, your right side, you have solutions, which is this part, and you have the sandbox and the solutions that you create with the language. This is a model. And the next model is Constance, is your language. You cannot see there, but I will just tell you what it is. It's all like the aspects that you need to create this language. The first one is structure. The structure is how you're going to structure the abstract syntax tree, all the nodes, to create your language. The second one is the editor, which is the visualization part. How it's going to be seen, the user is going to be see the language. Constraints and behavior are these two options, which is the logic of the nodes that you're creating inside the abstract syntax tree. There's one model of type system to create the type system of the language, and the generator. The generator actually is the main thing because it's where the magic happens. It's where the part when you change like what you're writing from the editor and change it to the language or the target language that you want. Okay, so for this simple example, I will use a structure, editor, and generator. So for the structure, how much time I have? Okay, for the structure, I need to get this structure in a way that I will have setup constants as the root node, and then they will have children's, which is constant n number of constants. So for this, I have to create for this DSL. I will have to create this structure. So I will go to structure. I will generate two concepts. One is constant, and two properties, name with a string and value with a string. What I'm doing here is I'm generating one concept, which is like one node, with two properties, name and value. Now, the second concept would be the root concept, set of constants. Set of constants, this has to be root, so it's true. The properties will be name as a string, and the children will be the constants that we just create. from 0 to n. Okay, I don't know if it sits well, but this is like the second concept, which is a node with an attribute with a property of name, which is a string. And the lower part is the children, which is the list of contents, which I just referenced the constant that I just created. So what I just did, I just create this structure. Okay, now, if I generate the language, and then I generate the project, I should be able to create one solution with set of constants because it's our root node. So basically, now we have this structure where you can put full name with all the list of constants just written there. So if we go back to our presentation, what we're looking for is to have, okay, it doesn't say the well, but it says the name of my constant is name, and then all the constants that you have. So it's basically what we have, but with different visualizations. So now it's time for the editor. So we will create the editor first for the set of constants. I can either go in here and create an editor aspect. So what I need here, I will need to make a collection. And with the text, the name of my constant, the name of my constants, and I will reference the name of the property of the set of constants, and then I will create a new line. I'll create a new collection, a vertical collection, so all the constants, all the childrens will go in every line. There. I know that it's a little bit complex, but just stay with me. What I just did is just a visualization of the set of constants where I will put the text that I wanted to have, the name, the property, like the name of the set of constants, and then all the constants in one line vertically. Now I need to modify the editor of the constant. Okay, for this one, I also use a collection. Okay, it will be constant. Then the name, semicolon. Okay, wait. Then the name, then semicolon, then the value. What I just did here is I just create a constant, which is a constant, then the properties of name, semicolon, value. So now, if we rebuild the language, here, and we go to our solution, now it's making more sense. Now, we create one, name, Oscar, surname, Rodriguez. So now we have the visualization that we want from the beginning. So now it's time to make, but it doesn't do anything, it doesn't generate anything. So now we have to use the generator. So for the generator, we will use this, this is the part of the generator where you define all the rules, how you're going to use the whole structure. I think I have some information here. Yeah, just a little bit of background of how the generator works. We use model-to-model transformation, which means like in every node, I think I can make this bigger. Yeah, which means that every node, you have like the syntax that you're using in your DSL, and to every model-to-model transformation, you have to change it to the target language. In this case, you're changing from this mono language to Java. So you make all the rules and all the logic to change this to the target language that you want. So that's what we want to do. For this specific example, we need a root mapping rule. This means that what will happen when you create this solution of the root mapping, which is a set of constants. Okay, for this, I will create a Java class. So what happened here is if I generate it, and then I generate the code of this solution example that I have, I will just generate the public class of the Java, the Java, just the beginning, but nothing inside the class. So what I will do here is first I need to create public static final string field value. So this is what I want to generate, but of course with the information that I'm getting from the nodes, from the editor. So first, I want to change the name of the class to be the name of the solution, of the name that I have already established, which is full name. So what I will do here, I will use this property macros, that is how we call it in MPS, which is what we're doing, we're saying to the tool that for that name of the class, we will put the name of the node that we are inside. And the node that we are inside is set constants. And set constants, the name of the set constants in our solution is full name. So if we generate the code here, and we generate, and we rebuild the language, and we generate a code, now we have full name. Okay, that says full name. We generate now the language class says full name, the name of the class is full name. So now, just to go, okay, I need to go a little bit faster. Okay, for this, I will have to use one property that is called loop macro. What I'm doing is like the children of the set of constants will be looping this line of code, like the number of how many constants I have. And inside the constants, I will also modify the field. Okay, fast. Okay, I will modify the field with the name of the node of constants, and here the value. I will also use a property macro to put the value. So in this way, we just finished the language. We made it. So now if I go here and I generate the solution, or I generate the text, I already have my language of constants. So just to finish fast, back to the presentation. Let's try again. Okay, better we can do it like here. Okay, why bother? The benefits are that you increase productivity, the quality, and higher level of abstractions. Increased productivity, it means like in the beginning you have to make an effort to create a domain-specific language, but then once you create it, it's the support, it's less effort. And for general purpose language, you have to start from the bottom, like it's not a lot of effort, but then to make it the support and to make it bigger is the hard part, to increase the functionality. The quality, if it's shorter code, which means fewer bugs, it's easy to analyze and to review, like the examples that I show you. And the errors are domain-specific errors. So you don't get the errors that, you are the one that define the errors. High level of abstraction, which means you encourage communication, you encourage different teams to understand the code that you are doing, and you preserve the expertise of the domain. TSLs are using it in different industries, so it's not the TSL for a specific industry. We know of different kind of industry that are using TSLs. And well, these are other language core benches that they also create DSLs. Xtext from Eclipse, Intentional, Microsoft just bought it like last year, and Spoofax is a research project from a university in Netherlands. And just to make like the difference between MPS and other language core benches is that we have language modularity, which means that you can combine different languages, and projectional editing. And just to finish, because my time is over, I want to get finished with this quote from Sergey Dimitriev, which is the founder of JetBrains and also the father of MPS, which goes like this. Sure, I can do anything on a computer, but some things take me years of effort when it should take much less time. Something is wrong here. And that's it. Thank you.
And any questions?